Hi everyone, come let's go with priority list method. This priority list method pick from solution of the unit commitment problems. Priority list method it is simplest unit commitment solution method, consists of creating a priority list of units as a simple shutdown rule or priority list scheme could be obtained after an exhaustive enumeration of all unit combination at each load level. The priority list of example could be obtained in a much simpler manner by noting the full load average production cost of each unit, where the full load average production cost is simply the net heat rate at full load multiplied by the fuel cost. Priority list method is the simplest unit commitment solution, which consists of creating a priority list of units, full load average production cost equal to net heat rate at full load x fuel. Cost assumptions are: a no load cost is 0, unit input output characteristics are linear between 0 output and full load, startup cost are a fixed amount. Fourth one is ignore minimum uptime and minimum downtime steps to be followed. Then dynamic programming method. Dynamic programming has many advantages over the enumeration scheme. The chief advantage being a reduction in the dimensionality of the problem. Suppose we have found units in a system and any combination of them could serve the load. There would be a maximum of, for example, 24 minus 1 equal to 15 combination to test. However, if a strict priority order is imposed, there are only 4 combinations to try. Priority 1 unit plus priority 2 unit, priority 1 unit plus priority 2 unit plus priority 3 unit, then priority 1 unit plus priority 2 unit plus priority 3 unit plus priority 4 unit. The imposition of a priority list arranged in order of the full load average cost rate would result in a theoretically correct dispatch and commitment only. No load cost are 0. Unit input output characteristics are linear between 0 output and full load. There are no other restriction. Startup cost for a fixed amount. In the dynamic program approach that follows, we assume that a state consists of an array of units with specified units operating. The startup cost of a unit is independent of the time it has been offline. There are no cost for shutting down a unit. There is a strict priority order, and in each interval is specified a minimum the rest of line. It is a fixed amount. The amount of capacity must be operating. A feasible state is one in which the commitment units can supply the required load and that meets the minimum amount of capacity each period. This is traveling salesman problem. This gave for example of solvation. This is unit data mentioned for dynamic programming. This is demand data. This is feasible unit combination. This is transition between feasible combination, infeasible transition, minimum downtime of in unit A, minimum uptime of unit B. Feasible transition, operating cost chart, operating cost again, operating cost chart, startup cost chart. This is accumulated cost. This is total cost. It is optimal solution. Thank you.